Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 5, Lesson 7 on Systems of Inequalities. Throughout this unit we've been working with systems of equations, right? Two or more equations with two or more variables, and we're always trying to find the values of the variables that make all of the equations true at the same time. With systems of inequalities, we have almost exactly the same thing, except instead of having equations, we have inequalities. So let's jump right in and take a look at systems of inequalities and what it means to solve a system of inequalities. All right, we're only going to be using our graphing calculators briefly in the first exercise today. Pretty much most of this we're going to be doing by hand. But if you do have a TI Inspire, I want to show you something kind of cool that the Inspire can do on these types of problems. All right, so first let's talk about systems of inequalities. We can have systems of inequalities just like we had systems of equations. To solve the system, we need to find all the points that solve both inequalities. So let's start with exercise number 1 with kind of a basic inequality system. Exercise number 1. Consider the system of inequalities shown below. That system is x plus y is greater than 8, and y is greater than or equal to 3x minus 4. Determine if each of the following points is a solution or not to the system. Show work that justifies your answers. All right, cool. Well, let's do the first point together and then have you do B and C on your own. So just like with systems of equations, what I want to do is take the point 2, 9, substitute it into this inequality, substitute it into this inequality, and see if it makes both of them true. All right, so let's do it. Simple enough, right? For the first one, I've got 2 plus 9 is greater than 8. 11 is greater than 8. That is true. For the second one, I've got 9 is greater than or equal to 3 times 2 minus 4. That's 9 is greater than or equal to 6 minus 4, and 9 is greater than or equal to 2. That's also true. Because they're both true, that point is a solution to the system of inequalities. So no matter how I end up graphing this thing, 2, 9 ends up falling in the solution set. What I'd like you to do is now take a little bit of time to see if the next 2 points also fall in the solution set or don't. Pause the video now and take a few moments. All right, so let's go with 7, 3. Give myself a little bit of room here. First one, 7 plus 3 is greater than 8. 10 is greater than 8. That's certainly true. Excellent. 3 is greater than or equal to 3 times 7 minus 4. 3 is greater than or equal to 21 minus 4. 3 is greater than or equal to 17? No, that's false, right? So since that's true and that's false, the answer here is no. Okay, so nope, nope, nope. All right, now let's do the last one, right? 3, 5. Let's see, is 3 plus 5 greater than 8? Is 8 greater than 8? That's false. And right now I'm going to stop. I'm going to say no. All right, and I'm going to say no, and I'm not going to even check it in the other one. I don't need to check it in the other one. Remember, for a solution to be a solution to either a system of equations or a system of inequalities, right, every one of the inequalities must be true when you substitute the point in. So as soon as the first one's false, 8 is not greater than itself, right, then as soon as that's false, it is not a solution to the system. All right, so now let's talk about how to graph the solution set to the system of inequalities. I'm going to write them down here so that I can see them once I move that board up. All right, let's do it. Graph the solution set to the system of inequalities. Now, in the last unit, right, which was all about linear functions, we looked at how to graph inequalities in two variables. All right, so let's review how to do that. The first one I'm going to do is actually the simpler one, the one that's sort of already in y equals mx plus b form. So y is greater than or equal to 3x minus 4. First step is I'm going to graph the line that the inequality is based on, 3x minus 4. So what do? I come over to a y-intercept of -4, and I use that slope of 3 to graph the line. All right, now, Keep in mind, once I've plotted those points, I have to decide whether or not I need to connect them with a dashed line or a solid line. Because this inequality includes the equal sign, I'm going to connect those points with a solid line. Here we go. Right? Now I have to decide whether I should be shading above the line or below the line. Because it is y greater than 3x minus 4, I should be shading above the line. All right? So that will be this inequality. All right. Now, I should label this line with either the equation of the line or the equation of the inequality. It really doesn't matter which. My particular preference is to actually label it with the equation of the line. All right. In fact, everything, including the line and the shading, is actually y greater than or equal to 3x minus 4, but the line itself is just y equals 3x minus 4. Now let's take a look at this one. That one's a little bit trickier because it's not in sort of a natural y equals or y greater than or y less than form. But it's fairly easy to get it there, right? I can subtract an x from both sides. Now that doesn't flip the inequality sign, but it just makes it y greater than negative x plus 8. All right? So I am going to think about graphing the line negative x plus 8. That means I'm going to go up to a y-intercept of 8, and I'm going to use a slope of negative 1 to draw in these points, hopefully. All right, that should be enough for me to kind of get a sense for what's going on. Okay, now I have to think about, is the line dashed? Is the line solid? Since this inequality does not include the equal sign, I want a dashed line here. So I'm going to dash this line, right? I'm going to label it with its equation, y equals negative x plus 8. Okay, because it is y greater than x plus 8, right? What I'm going to do is I'm going to shade above it, all right? And that's going to be out here, all right? And there we go. Now, what is the actual solution set? A lot of times it's convenient to put a big S in the solution set. Well, remember, we would want all the points that make both inequalities true. Well, that's where the shading is going to overlap. So in other words, that's right up here. This is the solution set to my inequality because it is where both of the portions of the plane are shaded, right? And what's really cool is we can look back at these points, right? Remember the point 2, 9. That point 2, 9 did lie in the solution set. So take a look. If I go 2, 9, it's a little bit hard to see. Maybe I'll change the color here. So easier. 2, 9 is sitting right there. And that is in that double shaded portion. If I took a look at my second point, right, which was 7, 3, 7, 3 is over here, and it lies within one of the two shadings, but it doesn't lie within this shading. So it's also not a point, right? Likewise, we could even look at that last point, 3, 5, which lies right here, and it is close. That's really close. The problem is it lies on the dashed line, and the dashed line is not part of that region. All right? So it's pretty simple. To graph a solution set of a system of inequalities, you graph the two inequalities separately, all right, and you find out where they overlap. It is that simple. Now, I would like to show you in just this one exercise what the TI Inspire calculator can do for you, because it's pretty darn cool, right? In fact, let me bring out the TI Inspire right now, and I'm going to break out of my program here so we can look at this a little bit larger, all right? And in fact, I'm going to bring it out so I have my side screen. Now, what's interesting about this is instead of putting in a function, I'm going to go to my menu, I'm going to go to Graph, Entry, Edit, and instead of function, I'm going to put in what's called a relation, okay? And the cool thing about a relation is I don't have to have it as y equals anymore. I don't have to have that, right? All I need to have, let me just move this for a second so I can bring these back up. Don't worry, I'll bring it back out in a sec. Here we go. Is I just need to have those two inequalities. So here we go. I'm going to type that first one in literally the way it looks. Relationship number one, x plus y. Now, how do I get that greater than 8, right? Well, this is going to be hard for you to see, but right above the equal sign on the TI Inspire in a little blue symbol, you see a not equal sign and a greater than or equal sign. If I hit Control equals, then it pulls up all of those inequality symbols, and I just want greater than 8. Hit my down arrow, and that puts that one in. Now I'm going to put in the second relationship, which is y is greater than or equal to 3x minus 4. Enter. All right, now I'm going to even make the window so it looks as much as like my graph as possible. My window was -5 to 10 and -5, whoops, nope, that's not what I want, and -5 to 10. And now let's compare the two. Bring it back out. A little more. There we go. That's a little bit better. All right. Really, really kind of amazing, this technology. You know, with the TI Inspire, I don't even have to rearrange that relationship x plus y is less than 8. I don't even have to do that. Now, one thing that's probably pretty hard to see, but one can see on the screen, is you can even tell that this one is a dashed line and this one is a solid line. It'll even shade in the right direction, right? It's shading above this one, it's shading above this one, and then even cooler, right? You get this sort of like mixture of the two colors. A little bit hard to see here, but this is pink, blue, and maybe dark pink. I don't know. But you can certainly see where that shading overlaps. And again, it's this region in here, right? That region that encompasses where both of the inequalities are true, that is the solution set to your system of inequalities. Let me put that back away. Anyway, that's the only time that we'll use that. Today, I just kind of wanted to show you that special capability. In the next lesson, we'll use that quite a bit. But for now, let's go on and just do a little bit more graphing. All right. The solution set to any system of inequalities will be the region in the xy plane where the shading for both of the separate inequalities overlaps. It's where they intersect. Right? You know, think about solving a system of equations graphically, right? Where we graph the two equations and find their intersection point. That's exactly what we're doing here, except we're finding a lot of intersection points because we're looking at where that shading overlaps. Let's take a look at exercise number 2. On the grid shown below, graph the solution to the system of inequalities shown below. State a point that lies in the solution set and one that doesn't. All right, this is cool. Well, what I'd like you to do is pause the video now and try to sketch both of these inequalities on this particular graph grid. The first one I hope you have no issue with at all. The second one might be a little bit more confusing, so if you're not sure what to do with that one, hold up on it and we'll obviously go through it. So pause the video now and take a few minutes. All right, let's first go with this one. Again, what I want to do is I first want to think about graphing. Ooh, maybe change that back to blue and maybe a little bit thinner. I want to think about graphing. I want to think about getting rid of my y. There we go. I want to think about graphing y equals -3/2 x plus 4. So I'm going to go up to a y-intercept of 4. I'm going to go to the right 2 and down 3, right 2, down 3, etc. Left 2, up 3. Come on, left 2, up 3. All right, because it's an less than only, not a less than or equal to, I'm going to put in a dashed line. All right, because it is a less than, not a greater than, I'm going to be shading underneath it. All right, and I'm going to label that line with its equation or with its inequality. Either one is fine. All right, so that's the first one. Now the second one's a little bit trickier because it's x greater than or equal to 2. Now keep in mind, I still want to do basically the same thing. I want to first graph the line x equals 2. Now x equals 2 is probably the most confusing of all lines to graph because it is a vertical line, right? This is a vertical line. It's all those points where the x coordinate is 2. Now, because it's x greater than or equal to 2, I draw that line in solid. All right, so I'm going to write x equals 2 right beside it. And now where do I shade? Well, I shade to the right of it. Hello. I shade to the right of it because it's greater than 2. And then I shade over the mysterious red. So where is the solution set? Well, the solution set is where they overlap, right? I'll put a giant S there for solution set. Right, it's that kind of smallish triangular area right down there, okay? Now, the problem also asks us to state one point that is in the solution set and one point that is not in the solution set. The solution set, it actually takes up a pretty small amount of area on the grid that is currently shown, okay? So I've got a lot of choices still within it, but let me just put a point right here. That's the point 3, -2. All right, now again, there are many points that you could choose, but that is one point that lies in the double shading. Now, as long as you pick a point that's not in this sort of little triangular region, right, as a point that's not in the solution set, so you could have a point in this shading, you could have a point up in this shading, you could have a point here where neither one of them is true, all of those would be good. Every single one of them would be a point that is not in the solution set. I maybe will choose this point here. That's 1, 8. And that's a point that's not in the solution set. So really, this is a wonderful extension of two things that you already kind of understand, I hope, right? From the last unit, sketching a linear inequality in two variables, right? And secondly then, how we solve a system. And we solve a system by finding the intersection of the two things. If there are two equations, those intersections are just like a single point or a couple points or whatever. If there are two inequalities, that intersection is where shading overlaps. All right, let's keep working with these. Here we go. Problem 4. Sometimes, not problem 4, problem 3. Sometimes we will be given the graph of a system of inequalities and we'll need to model them with algebraic inequalities. So in other words, let's take a look at exercise 3. State the system of inequalities that has its solution set shown below. All right, so this can be a little bit tricky, all right? And the first thing I would suggest doing is thinking about the equations of the two lines that these two inequalities are based off of. So pause the video now and see if you can figure out simply the equations of the two lines. Don't worry about the shading, don't worry about greater than or less than or anything like that. Just try to come up with the equations of the lines that sort of bound the shaded area. Pause the video now. All right, well, let's first talk about this line right here, the one that's kind of coming down here. That's the one that's dashed, but whatever, right? If I come into this line, and I think I'll change my color, right? What I've got is I've got a y-intercept of 5, and if I can mark some points on it, what I notice is that I've got a slope of 3, right? I go to the right one and up 3. So that's simply the line y equals 3x plus 5, right? On the other hand, this one right here, the one that's solid, that one has a y-intercept of -1 and has a slope of 1/3, right? You're going to the right 3 and up 1. So that's going to be y equals 1/3 x minus 1. Okay. So I've got the equations of the two bounding lines, if you will. Now what I want to do is actually phrase it in terms of inequalities. Let me start with the y equals 1/3 x minus 1. Notice that one has its shading above it, right? That thing is shaded above it, and it's a solid line, right? So that means it's going to be y is greater than, right? That shade's above or equal to, that gives us the solid line, 1/3 x minus 1. Okay, so that sort of takes care of this line that has a slope of 1/3 and is shaded above it. Now my other line, right, my line y equals 3x plus 5 is dashed and shaded below. So for that one, because it's shaded below, it'll have to be a less than. Because it's a dashed line, there's no equal sign, and then it's 3x plus 5. So there is my system of inequalities that has been graphed on that grid. All right. Now again, what does that boil down to? It boils down to being able to figure out the lines, the equations of the lines that are graphed, and then knowing if they're dashed, right, we don't include the equal sign. If they're solid, we do include the equal sign. And then it's about knowing whether we've shaded above, in which case it's greater than, or shaded below, in which case it's less than. All right, let's tackle one more problem. 3 or more inequalities can close off, or what we call in math, bound a region in the xy plane. Keep in mind, a point is only a solution to the system if it makes each inequality true. So let's take a look at exercise 4, where we've got 3 inequalities that we're graphing. Consider the system of inequalities given below. Y is greater than or equal to -2, x is less than 4, and y is less than or equal to 2x. Letter A, determine which, if any of these points, is a solution to the system. All right, so I'm just kind of curious. I've got these 2 points. You see if either one of them is a solution to the system of those inequalities. Play around with it right now. All right, well, it might seem a little bit weird because here we've got this point, -1, 4, and the first 2 inequalities are probably a little bit tricky to even think about, and yet it's simple, right? My first inequality is y is greater than -2. Well, is 4 greater than or equal to -2? Yeah, that's true. My second inequality is x is less than 4. Well, what is my x coordinate in that point? It's -1. Is -1 less than 4? Yeah, that's true. So far so good. And my final one is y is less than or equal to 2 times x. So that's 4 is less than or equal to -2, and that's false. So the answer there is no, right? -1, 4 is not in the solution set of this system of inequalities. Why don't you go ahead and play with the point 3, 1. Take a moment again on that. All right, let's do it. So again, first things first, y is greater than -2. Well, is 1 greater than or equal to -2? That's true. All right, second one, x is less than 4. Well, is 3 less than 4? That's true. Finally, is 1 less than or equal to 2 times 3? Is 1 less than or equal to 6? That's true. Since every one of the inequalities is made true using that point, the answer is yes. Now again, keep in mind what that means. What that means is that when I eventually graph this inequality, right, this point will not lie in the overlapping shading of all 3 inequalities, and this one will. Okay, that being said, let's do some graphing. Let's take a look. Letter B. Sketch the solution to the system on the grid provided. All right, wonderful. So what I'd like you to do is pause the video now. The picture's gonna get a little ugly. I'm not gonna lie to you, right? Because there's gonna be 3 inequalities that you're gonna graph, and you're gonna be shading all over the place. It's gonna get messy, all right? But why don't you go ahead and try it? Take some time now to go ahead and do this. All right, so first things first, y is greater than or equal to -2. The first thing I'm going to do is graph the line y equals -2. Now, because it's greater than or equal to, I'm going to draw that line in solid. Okay, there's my line y equals -2. I drew it in solid because of the equal sign there, and I want greater than -2. So that's going to be all of this up here. All right, second one, x is less than 4. That's going to be the vertical line x equals 4. Okay, but I need to make it dashed because it doesn't include the equal sign. So now I'm going to shade this way. All right, and finally this one, y is less than or equal to 2x. Well, first I want to think about the line y equals 2x. Now that's a very simple line to graph, right? It's a line whose y-intercept is the origin and whose slope is 2. So 2 over 1, right? Now, because it's got the equal sign with it, I'm going to draw that line in solid. Right? So there's my y equals 2x, and it's going to be less than. Man, that is a mess. That's a mess. Here we go. So it's a little bit tricky, all right, to even see what's going on here. But the triple overlapped area is this triangular region right in here, all right? Now, in fact, maybe what I'll do is I'll kind of outline it in red, okay, just so that you can see it better, right? It's a region that goes from here down to here, across to here, and then it really has a dashed line there. That is the solution set to my inequality. Let's take a look at letter C. Find the area of the portion of the xy plane that represents the solution. So in other words, find the area of that triangle. Pause the video now, see if you can remember how to find the area of a triangle. All right, well, let me go back to blue, if I can. There it is. Blue, right? The area of a triangle is 1/2 its base times its height. Now what I've really got here is I've got a triangle that kind of looks like this. It's a nice right triangle. Its base, if I look very carefully, is 1, 2, 3, 4, 5 units. Its height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. I think. Let me just make sure of that. 8 down to -2, 10, yep, 10 units. And therefore, the area is 1/2 of 5 times 10, which is 1/2 of 50, and that's going to be 25. So the area is 25 units, 25 square units, however you want to call it. Now, one more little philosophical question that I think is kind of cool to ask in this situation. Let's take a look at letter D. Why does the dashed line of one of the borders not make a difference in terms of the area you found in part C? In other words, really, this is a triangular region, but this one border is dashed. And why do I not even have to think about that when I calculate area? Pause the video now and see if you can write something down. Well, it's pretty simple, right? Especially if you understand the concept of area. Area is a measurement of the space inside of an object. So the border doesn't matter, right? Whether the border is included or not is sort of irrelevant. Area is the space inside the region. The border doesn't matter. We could have had all 3 sides of the triangle actually as dashed lines, and it still would have been an area of 25 square units. All right, let's wrap this up. So the cool thing about systems of inequalities, right, is that they are simply, at least in this course, 2 inequalities with 2 variables. How do you solve a system of inequalities? Well, there's no real way to algebraically solve them. Not really, right? The way that you solve them is you graph the 2 inequalities and you find the section of the plane that represents the overlap of their shading, right? I guess in that last exercise we had 3 inequalities, which got to be a little bit ugly, right? But ultimately speaking, you're still looking for where the solution sets of the individual inequalities overlap with one another, and those then become the solution set to your overall system of inequalities. We're going to work with this a little bit more in the next lesson when we model real-world scenarios with systems of inequalities. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.